In a typical application, you have a production environment. So in this case, it's acme.com, and you have a staging environment where developers typically test changes. Um, so we have several developers here. So developer two, developer one, and both of them are developing locally and pushing those changes into staging. Um, what happens there is that certain features take longer to develop than other features, and developer 2, for example, might need to deploy his changes as well, and that could cause a merge conflict on staging. And if you add more modern tools like agent developers from Cursor or from Codex from OpenAI, they can execute changes more quickly and make even more pull requests, and you can merge even more changes into the same staging. And this will be a mess because no matter how fast you will develop, you will have this bottleneck of a single staging. So this is where preview environments come in. As you can see in this example, we have not one staging, but four staging environments. What happens is that the development happens in parallel, and regardless of how many features we develop or how many tasks we assign to background agents, we will have separate staging or preview environments for those changes, and they will never conflict. And effectively, this will allow us to develop much faster without sacrificing anything in terms of quality. So this is not a new thing in certain platforms. For example, in Vercel, you have preview environments built in. Many people use it. But what happens if you have an infrastructure on AWS and GitLab or GitHub or Azure? Usually teams tend to fall back to the staging approach. And you don't feel it at first, but you are developing slower because of that. So in this video, I will show how to set up environments on AWS to have the same experience you would get on Vercel. So whether you have requirements to use AWS from the legal side, or simply the rest of your services is already running on AWS, so attaching a new provider is not possible, I will show you how to get the same effect on your own, basically. So I will start with a real-world example, actually. We have two merge requests here. One of them is actually made by Codex. It has the Codex label, so it was just done in the background. I can even open it. It was instructed to make a color change in footer for this example. And it made a pull request. The other one was made by me. And you can see if I click on the merge request, I scroll down to where GitHub Action bot left a comment, and you can see that it generated a domain from CloudFront with this change. And if I open it, and I will go to the blog, I will go to the single page, and you can see that the image is using source sets. If I compare this with production, and I will inspect this, you can see it uses a single image with Next.js defaults instead of the picture tag. So even though the production has a different version, this particular preview environment has my change. If I go to another merge request, for example, the footer styles one, it has a different link for that particular change. So if I copy it, and I will paste it, you can already see that the footer is black because the color was changed. And it's isolated from the production and from the other preview environment. So you can see how I could add 10 more features in parallel, or changes or bug fixes, and they would not interfere with each other. So I could release them whenever they need to be released without necessarily cleaning up my staging, because there is no staging environment. There are preview environments. So this is how it works in action. Let's go into the implementation part. So the first step is to configure AWS. You create a IAM user, you assign the permissions to change resources in AWS, and then you copy the access token and the secret token. That's all you need to do. You don't need to create those environments manually. This will be done through GitHub Actions. I will show you how later. The next part of configuration is to configure the environments. So as you can see in GitHub, I have two environments, one for production and one for preview. And if you can see, I have secret access key and key ID from AWS I just copied. Of course, for this website, we have more secrets, but this will be specific to your application. This is the configuration level. We can have a look at the code level right now. So if I open my IDE and we can look at the preview environment, the most interesting part really is this section here. We're defining a variable called SST stage, and we're actually pulling it from GitHub Actions. So GitHub event, pull request number, very straightforward. So from pull request, from merge request, we're going to pull the number, prefix PR, so it's clearer, and then we're going to run an npm command to provision resources for that environment. So we're leveraging SST stages for this. We're not really inventing anything. SST itself will provision the needed resources for that stage. And there is no limits to the stages you can have. You can have hundreds of them if needed. So when we combine that, what happens is, if you go back to the example, a merge request is created. It doesn't matter who created the merge request, whether it was an AI bot or a human. This GitHub action was run, the PR number was taken, and AWS provisioned resources for that particular environment. And in the end, we're just calling the GitHub bot to inform the other developers here that this was created, and we can preview the changes. And that's it. This is how it all connects. So if we come back to the diagram I showed earlier, you can see that all these environments are created one by one instead of me merging everything to single stage environment. The other part of this is the cleanup GitHub action, because after we create a GitHub environment, we also need to clean it up. Because if you don't clean it up, we'll provision resources in the AWS that will not be used after the merge request is canceled or merged. And that's it. And after it's merged, we're calling the production action. And it's actually simpler than the preview one, because it only needs to deploy the resources to hard-coded stage, which is production. And that's it. With all of this, you can have the same effect you would have in something like Vercel. And it runs on your own infrastructure. You can imagine that I could use different resources as well, maybe from Azure, from Google Cloud. I could port this configuration to GitLab Actions instead, and the workflow will be essentially the same. So that's one part of it, but if your application is more advanced and you have databases or load balancers, maybe even cache configuration, then you can start to think that, okay, but if I have multiple staging environments, will I have to provision a different database for each environment? The answer is no. There are solutions for that as well. So if you look at one of the solutions is you can have database branching. So for example, if your database schema changes in a particular feature, you can connect GitHub Actions with something like NeonDB, and it will create a different branch in your database. So you will only pay for one database, but you'll have multiple branches as well. The other option is native to SST, so no another provider is needed. It's just sharing resources. So you would have configure one database and share it across the stages. So when combining those two approaches, you can pretty much replicate whatever you need in the preview environments. So you can still have fast development and can still share the resources, and you're not blocked by a single staging environment. The last thing I'll mention, I found this through testing, is you also might want to think about concurrency. So, for example, if you merge the merge request sooner than the resources are provisioned, because it takes some time to provision those resources, then you need to handle the cleanup in a sequential way. You don't need to, you can't remove them before they're created. So for this, I basically configured this concurrency group. And I'm basically saying that I'm going to wait for the merge request to be either closed or merged until I do another action for the same branch. This way you don't have messed up configurations in AWS. It's one of those skills where you learn it once and then you can apply it to different kinds of applications and different kinds of cloud. You're not limited to one provider. So I think it's definitely worth time investing. And another benefit is you will see the difference when developing. And when you need to go back to one staging, you will see that, oh, that was not as optimal. So hope it was useful.